In an insurance company, 3 actuarial assistants, A, B, and C, okay, are assigned to process loan application forms against the policies. A processes 40%, B processes 50%, and C processes 25% of the loan applications. And you'll just note there that 40% plus 35% plus 25% adds up to 100%. So there's nobody else. A, B, and C do everything. Okay. Now the error rate while processing the loan applications by A, B, and C are 0.4, 0.6, and 0.3 respectively. So a loan application was selected at random by the branch manager and it was found to have an error. What was the probability that that was processed by A? Okay, actuarial student or assistant A. So let probability of A, B, and C denote the probabilities that they were processed by actuarial assistants A, B, and C respectively. Just actually, it's sort of set up fairly well in this question and sort of signposted. But don't forget to do something like that. Just spell out what your notation is, okay? Just even a little sentence like that. Don't assume. Well, we called them A, B, and C in this case, but don't assume that if they had names like Alan and Barry and Kira, that A, B, C would correspond to that. Just spell it out, okay? Also, spell out this sort of stuff here. Just take a minute to just write all this out. Be clear about what you mean by everything, okay? Now, let E be the event that the loan application contains an error, okay? So, we're told that the probability of E given A is 0.4, so that's the probability of an error given that it came from A, okay? It's a conditional probability there, 0.4. Likewise, the probability of an error given that it came from B is 0.6, and the probability that an error happened given that it came from C is 0.3. So this is conditional probability is what we're looking at here, okay? Conditional probability. And we're asked to compute this. Given that there was an error, what is the probability that it came from A, okay? So that's what we have to find out. So we're going to take this in 2 stages. We're going to first off find out what the probability of E is, okay? Now, probability of E is probability of an error, okay? And we can divide that up into 3 component events. A union E, which means that it was caused by, it was an error and it was processed by A, plus the probability of B union E, there was an error and it was processed by B, and likewise C union E, there was an error and it was processed by C, okay? Now, so, my pen is slipping there. So the important thing to do there is actually recognize that this is where we would use conditional probability. Okay. Now, hopefully you'll be a little bit. This is not the first time you've seen a conditional probability formula here. But essentially what I can do is restate this expression using the conditional probability formula as that. Likewise, I can restate this expression here using the conditional probability as that. And finally, this one here using the conditional probability formula stating it as that. Because these are products of 2 terms here, but we know what both of those terms are. Okay. Now, I've sort of gone a little bit back and forth in terms of precedence there, but we're fairly okay really. So probability of A is 0.4 times the probability of E given A, which is 0.04, which should work out to be 0.16. Okay, or 160. Anyway, so essentially a little bit of calculator work. Okay, I shouldn't do that in my head, but it should work out to be 0.0445. That is the overall error rate. Okay, so again, that the real trick of this question is just spotting that you can use the conditional probability formula very easily. So moving on to the next part there is there's actually sort of thing called the Bayes theorem actually. So we could have used this earlier on, okay, but we have it there anyway. So probability of x given y can be written this is the conditional probability formula here, Okay, but we can extend it out a little bit further reusing the conditional probability formula there again. Okay, so yeah, that's what we'll do. So essentially what we can do here is probability of A given E can be written as probability of E given A times probability of A all over the probability of E. Now, this is really just using the conditional probability formula twice in combination. Okay, so ultimately what we have above there is really just still the probability of A union E. Okay, and that's divided by the probability of E. Okay, so if you want, basically what I'm saying is, if you want to break this up into stages, that's fine. Okay, so we actually worked that out before. Probability of A times the probability of E given A, that was 0.4 times 0.04, which I was going to attempt to do in my head, but I shouldn't. But essentially it's a little bit of calculator work. 0.4 times 0.04 divided by 0.0445. Little bit of calculator work, and that should be close to 0.36, 36%. So that's it. We'll leave it there. And the key thing here really is a conditional probability formula. And if you want to sort of try and level up a bit, Bayes' theorem as well. Okay, we'll leave it there.